Hi, so this is going to be a short video on acyl chlorides and their reactions. So we're going to start with how we prepare an acyl chloride. It's better white than that. So acyl chlorides are prepared using SOCl2, phenyl chloride, sometimes referred to as Socyl2. So if we take a carboxylic acid, add our SOCl2, we are going to get, first of all, our acyl chloride plus sulfur dioxide and some HCl as well. So if we were to do an example of ethanoic acid, plus SOCl2, we'd get here our ethanoic acid plus SOCl2, we'll get here F and oil chloride as our product. And that's the preparation. So we'll look at some reactions next. I don't think this board rubber's working that well, so we'll go on to a new board. So in general, acyl chlorides will react with any nucleophile and replace the chlorine with whatever that nucleophile was, plus Cl minus. Nucleophiles could be ROH, could have H2O with the oxygen with the H2O, or ammonia as well. So there's a few different ones we're going to look at. So first off, we'll go with an alcohol. So acyl chloride plus R, I'll put dash OH, is going to go to an ester. Where the Cl is replaced by the R and the O that we've got here. That leaves our H to join with the HCl. Sorry, with the Cl to form HCl. Next up, acyl chlorides with water. In this case, we're going to take the O and H from the H2O and swap that in with the chlorine, substitute it in. It's a better word to use. And we'll get HCl again. One of the hydrogens is going to join with the chlorine to form our HCl, but we'll also get here our carboxylic acid. Next up, we'll have a look with ammonia. So with this one, I'm going to use excess ammonia. So plenty of ammonia in there. We're going to get NH2 forming here. Now we've got two NH3s here, plus the hydrogen that didn't join on. So only nitrogen with two hydrogens joined on. So we form here the ammonium ion, NH4 plus and Cl minus. So ammonium chloride forms there. And then if we take an amine instead of ammonia, so let's take R-NH2. So in this, I'm going to take two of them as well. In this one, I've replaced one of the hydrogens with an alkyl group. And what happens here is we get that NH forming with the R- group. Now this is, up here we had an amide. This is a secondary amide. So primary with two hydrogens on the nitrogen, secondary with just one hydrogen on the nitrogen. And we'll get over here RNH3 plus, so RNH2 plus one of the hydrogens that didn't go onto here, Cl minus. So we get that forming there. Ammonia must be in excess in this reaction. And that is the reaction to the acyl chlorides.